All right, so let's continue on. Um, let's see about finishing the problem as given, which was finding a word in a matrix. This, of course, is very similar to tic-tac-toe. So we have a method where we found, using the index, we found the index of the word in the matrix if it's in a row, right? So let's save that off. One of the things you'll see is in using let statements, right? You will see how let statements are, in a sense, precursors to variables, and you build up a series of variables, which of course can be bound to functions, and then you use them in the body of your function, right? So let's call this index, right, found as a row, right? So if it's found as a row, it's going to be an index, a number, otherwise it's going to be false, right? We'll deal with a number later. Okay, so that's great. Um, and we can verify that we still get something returned by typing found as row, and we will run that. All right, Control Shift. Oh, we don't need another terminal, so that was silly of me. All right, so we run it, and we get false, right? In theory, just move something. So why are we getting false? It couldn't find word in matrix. Well, don't really expect you to know this, but this obviously whatever word was trying to be found in matrix couldn't be found when it was down in the body. So did matrix change at all in any of this? No. But has word? Yes, word gets redefined in the let. Well, in regular let statements, they're just a series of variable bindings, but they are not allowed to interact with each other. Let star means you can use previous definitions in following ones. So now this word relates to a previously bound variable if it exists. So now if we run this, right? Great, 3. So there's let star, let rect. There's a whole theory behind this, right? This is all coming from Lisp, so there's a ton of theory behind this. And let statements, if you read some of the older theory books, you will absolutely come across let statements, right? And they even relate a little closer to lambda calculus, which is somewhat of the fundamentals of the theory behind computer and computer science. Okay, so we found mass, great. Now it may or may not be found as a row, right? So what we need to do is we need to create another found as a column. And how do we do this? Well, some of you probably have already solved this, right? But essentially we need to turn rows into columns. How do we do that? We essentially walk the first element of each of the lists will become another row, right? So essentially we need to transpose it. Well, what is the function in Elixir for this, right? How do you walk over each element from a set of lists? That is zip. So go look up enum zip. Here I have to find it in Racket, right? What is zip? And I don't know what it is actually. So this might take a while to find what it is. And it may also be that there's no built-in, and I happen to know a function that I may have to end up using, but let's see if I can figure it out, right? So what do we want to do? We need to turn a list of, on the left side here, I'm going to run Racket, and I'm not going to run it successfully, so we'll just type it correctly. So we'll make a list, and it's going to be a list of lists, so it's going to be 1, 2, 3, oops, and 4, 5, 6, and of course 7, 8, 9, the old classic 1 through 9. All right, so we have a list, and of course, oh my god, I'm such an idiot, not even in the right language. Define list. I do not know why I could do assignment or binding. There we go. Okay, we have a list of lists. So I need to go through each of them. So it's very, in Lisp functions, there's a very important method called apply, and we could go into it, but I'm not going to right now. But apply kind of allows us to do something like this. one nice thing in Racket, right? The plus operator takes 1 to n functions, or arguments. So you can give it a number of arguments, and it will sum them, right? Because we're adding them together. So essentially, plus is just sum. But if it's a list, what happens? Right? Let's see. Right? Well, it can't actually sum a list, but what you can say is you can apply the plus procedure to a list, which is effectively what we did in the line of 2 lines above. So let's see if I did this right. So when we apply something, so all right, so whatever, right? How is this going to help us? Well, I don't know yet. I need to walk through each list, and how can I maybe do that? I'm just going to try. I'm going to play for a second. If I apply list to L, right, what do I get back? I get the same thing, right? Because I take each list in L and apply it, right? But what if I apply car to each element? Car being give me the first element. That's the wrong arity, right? Because car takes a list, not a list of lists. Car of a list. 1, 2, 3. Right, gives me the first element. Wonder if there's other cars. Let's look at car. See, we have something called list star. Just like stars are going to be interesting. Like list, the last argument, oh, it's used to find the tail. All right, so I think I'm going down another not useful path. So I'm going to go into some of our iteration methods in Racket. So I'm going to whip up one. Again, we're in the terminal on the left. So we have for list in a item in a series of items, 1, 2, 3, right? And I just want to return each item, and this is essentially a list comprehension, right? I'm going to iterate over something. I'm going to return a list. This is basically list comprehension. For list comprehension. Okay. But if I remember what's kind of cool, and you can do this in list comprehensions, but not exactly. If I give another list, let's say J is going to be this magic. Oops, not 2, 3, 4, but 4, 5, 6, right? I'm going to close off that paren, and this square bracket closes off the iteratables I'm using. And now let's just build out a list of I and j as it iterates over. Cons is essentially building me a pair. It's not really a list because the tail is not a list. This is building me pairs. And because I'm in a list comprehension or a for list, I should get a list of pairs back. And I do. And they are effectively zipped as we wanted, right? So this for loop is essentially used this way with multiple iterators. It walks down each iterator and element one at a time. Great. In case you're curious, how do I get the list comprehension that's more like elixirs, if I remember elixirs, where for each of the first list, it iterates through the second list. I believe it's a 4-star. Or the star could be at the end of the list. I never remember where the star goes. So, yes. Well, I put it in the right place. So now, for every element in the first list, it iterates over the second list, right? And this should be more of what Elixir does. And let's just whip it up and see. For I in, right, 1 dot dot, I hope it's +1. Is it 1 to 4? Anyway, can't remember. We'll see. It doesn't matter. And then for j in 4 dot dot 4, 5, 6, 7 do, and then I want to return a tuple of I and j. And I in this, and I get my list of 1. Oh, and I get 4, so it is inclusive of the bounds. So let's just run it again because that's annoying to compare. So if it's inclusive of the bounds, then these should just be the values I want exactly. And then end. So now I have 1, and then I have 4, 5, and 6, and 2, 4, 5, and 6. So this list comprehension is exactly the Racket one. Exit this, get into Racket. I think it has, yep, it remembers, right, which is very nice. It has read line. Same thing, right? I created pairs, a tuple, 1 for each using the star, but if I don't use the star, as I've said 6 times already or whatever, this is effectively a zip. So this is what I want to do here. I want to zip them up, right? And when I build them, what am I zipping them up with, right? I'm going to get each one, but of course they're in matrix, which matrix has matrix is really a list of lists, so unfortunately I have to go back to my testing. Define and L as, oh wait, I think I already have L as correctly defined. I don't, because I had it in different, but I have it in history. Okay, so for list of item in L, of course, this is not going to give me at all what I want, because I'm not going to have multiple items. I'm just going to have each back. So I need to apply it. So how do I do this, right? There's a bunch of 4s. So let's go over if there's a type of 4 that does what I want. If I can give it a list of enumerables that it essentially unzips. Racket reference, list comprehensions, 4 or 4s, right? These are all very similar. These have pretty much a one-to-one mapping with much of what's in enum. So I have 4 for list, 4 sums, products, 4 folds, right? 4 fold, essentially reduce. So I've got stars, 4 lists, 4 lists, star lists, 4 lists. Let's see what this says. Similar 4 lists, but the last body expression should produce as many values as given in IDs. Okay, so this isn't still where I have 1 value. 4 derived, I don't see it. So now I might have to get fancy. I do not have an answer here. Apply for list. Can't apply it because it's not really a function, it's more of a syntax. So I need to pull it together. What the hell am I going to do? I need to walk through each element. We're back to figuring out what is their version of zip. Finding the scope, blah. idea what zip is. Just get to listen to the music. I'm sure there's an easy way to do this, right? Because it's a functional language. Must be an easy way, and I'm just not knowing it. Okay. List and comprehensions, right? Come on, man. Figure it out. Well, now you'll get to, let's see, Racket. Zip, quib, equivalent. Zip function, Racket. Great. What the fuck is it? Oh, fuck. This is what it is. Oh my god. Awesome. I knew it, and I couldn't figure it out. So we're going to map. What are we going to map? If we map plus, let's just see how this works. Five, 7, 9. Yes. Mapping. Let's go look up map. This map feels. You can take multiple iterables, which is where I should have remembered and been smarter. Applies procedure to the elements of the list from the elements of the list from the first elements to the last. The browser accepts the same number of arguments as the number of lists surprised. God damn it. Awesome. So it's actually simply mapping over. So if we say turn into a list, our list, that's still not it, but there's probably or map orange. Find all the normal filtering. Okay, still missing. Yeah. Forget all this. This is too complex because we already know what it is. Yeah, it still is apply. Interesting, there's a function that might handle this. Zip, define zip, list. My god, does apply do multiple things. Take a procedure and something and apply it to any number of lists. Applies a procedure using the contents of list star as the bypass. Oh, Jesus. Given procedure must accept as many arguments as the number of v's plus the length of list. Okay. Given procedure must have as many arguments. How long have I been going? Alright, almost another half hour and I haven't even gotten anywhere. Figuring out how to do lists zip in Racket. Okay, this doesn't really make sense. Holy shit. Okay, that's it. Speaking of... 1-4, yes. Alright, what the fuck are we doing here? Okay, so we're going to apply a procedure, right, which is map, yes, over some value and then some number of lists. So first of all, let's even use it, and then we'll get back to understanding and apply map list over matrix, right? And that gives us a list back, so we're not doing our for loop because we can do our same index of, right? And let's make another search string. The other one was foam, which was the first column. Was it foam? F-O-A-M. Yes, F-O-A-M. And give it a different variable name. We'll go down and we'll print it. And of course, we can run it twice and print it. We can be a bit silly. Column. And if we run this, what happens? Line 40. Save. Okay, yes, good. Found as row, found as column, index of applied as list. I'm applying some, or I'm indexing, but I didn't actually go look for something. So we print a phone and whatever, running it twice. Mass in our list, mass, found it at 3, and of course false comes from it's not found as a column. Mass, phone, oh yeah, each time we're searching it there. That's fine. We should probably take that out. In fact, let's just do it and clean this up. So, even move this down into the let. Since the let is not looping, there's no problem. Alright, let's try this again. Separate, so let's take out our, we'll only add our extra character turn at the end, so that thing obvious. Okay, list, word we're searching for. Found it at 3, and it's not found as a column. List, word we're looking for, not found, found as the first row. We've done our zip, we found it. So I'm done for the moment, at least for this 30-minute video. It's going to be another 100 megs. But let's go figure out how this apply is working, because this is awesome. Alright. So we apply a procedure, map. We all know what map means. And what? None of their examples give us 3 items. So the given procedure must accept as many arguments as the number of v's plus the length of list. Well, the number of v's is 1 because I have just list. And the length plus the length of list. And the length of list is 3. So what, 4? Procedure must accept 4? Oh. Because yes, apply is turning it into map list of each individual list. And this is where we get it. Oh, too many friends. Fortunately, yes, because map takes, because you expand out, map takes the function and the length of the list. This is beyond cool. I love this. This is why I like Racket and sort of these type of functional languages. It must accept supplied keyword arguments. It must not require any. Okay, fine, whatever. We don't care about that. So the key sentence is this, or even applies proc. Applies procedure using the contents of list star as the by positions as the arguments. What is list star? Like list, but the last argument that you use is the tail of the result. Oh, actually, so that means then list star of what? List L? Returns me a list. Oh, of course it does. Returns me a list with list meaning the procedure at the beginning. And then each list, oh, it's basically list star is essentially append. Okay. And if I apply this, yeah, that's not the right arity, but when apply, as it says, so go back, applies the procedure. The procedure is map using the contents of list star as the by. Oh, I didn't want to apply here, I just wanted map. Which can't be right, of course, either. But applies procedure. Applies procedure using the content of list star. Not sure how it gets the content out, but for the moment, get it, right? Go back to the original. Where was it? Apply map list. Out of taking list star, let's do list star again. List star of list and L, basically just, it's concat, essentially, right? We've got a list of 4, and we're going to apply that to map. Wish I could simulate it perfectly, but I can't. So we're going to stop here. I don't know how exciting this is for anyone, but yeah, I spent a half hour figuring out how to get zip in Racket. Awesome. Talk to you later.